Today we're going to look at factoring quadratic trinomials or three-term polynomials using our grouping strategy. So before we do that, I just want to consider, take it back a step, look at some multiplication. So we're going to multiply the expression 2x plus 4 and 3x minus 1. And I'm going to use double distribution here to multiply. So first I'm going to multiply 2x to 3x and negative 1. And that will give me 6x squared minus 2x. And then I'm going to distribute 4 to 3x and negative 1. So that will give me a positive 12x and a negative 4. So now that I have used my double distribution, I've got 4 terms here, and I have a couple of like terms to combine. I've got negative 2x and positive 12x, which combine to make a positive 10x. So all in all, I'll have 6x squared plus 10x minus 4. So let's look at what happened here. We started with a pair of binomials, so two-term expressions multiplied together. When we did that, we ended up with a 4-term quadratic function, right? It has a square there, and it's got 4 terms. And then we had some like terms. And so in the very end, we ended up with a quadratic trinomial, right? Power of 2 and 3 total terms. So when we factor, and our first example that we're going to factor is 2x squared plus 15x plus 18. And our goal is to write it as a pair of binomials. So some x term plus or minus a number times another x term plus or minus a number. And if we think about kind of how we're going to go from our trinomial to our two binomials, if we think about the middle step from our last work there, we had a 4-term polynomial along the way, and it was taking that middle term and splitting it up. So our goal here is to really think about how could I split up that 15x to make this a 4-term polynomial. Because everything else here in our multiplicative example, stayed the same. It was just those middle 2 pieces there that were different. So this is our goal here, is how do we take a trinomial and split it up into the correct 4-term polynomial so that we can use grouping. Now, we've got quite a few steps here, and the long story short is it takes practice. It takes a lot of practice to factor even a little bit well. So that's what we're doing, is we are practicing. We're going to make mistakes, and then we fix our mistakes and we get better. So the first thing we're going to do, and we are factoring, the quadratic that's up above, we always want to make sure that we write this in standard form. So remember, standard form is largest exponent to smallest exponent. And so it turns out that 2x squared plus 15x plus 18 is already in standard form. We have our largest power going down to our constant term. Step 2 is we always want to check for a greatest common factor. So we want to look at those 3 terms, 2x squared, 15x, and 18, and see what the greatest common factor is. So our greatest common factor here is 1. And normally I would say let's factor out our greatest common factor, but if it's just 1, it's not going to make a difference. So I'm going to make a little caveat here, unless our greatest common factor is equal to 1. If our greatest common factor is equal to 1, then we skip and we're ready for step 3. So step 3, we're going to identify our A, B, and C values. So remember, standard form is always kind of set up the same way, where we have A goes with the x squared, B goes with the x, and C is the constant. So we're going to have A is equal to 2, B is equal to 15, and C is equal to 18. So the first 3 steps are really pretty straightforward. We just got to make sure it's all cleaned up, neat and tidy, so we can find A, B, and C. Step 4 is where things start to get a little bit trickier, where we have to really pay attention. We're going to multiply A times C. So our A times C is 2 times 18 in this case, and 2 times 18 is 36. So maybe I should be recording these steps here. This is step 1 and 2, step 3, step 4, right? We have A times C, we get 36. And then what we're going to do, now that we have that 36, we're going to find all the factors of 36 so that we can find a pair that add to equal our B value. So factors, remember, are pairs of numbers that multiply to equal a third number. So I'm going to find my factors of 36. Oops. And I'm going to list them all out here in this case. With a little bit more practice, you may not even need to make a list, but I'm going to do that here. So 36 is 1 times 36. It's 2 times 18, 3 times 12, 4 times 9, and 6 times 6. So 5 pairs of factors here. And we need a pair that adds up to our B value. And our B value in this case is 15. So which pair of factors will add to 15? Oh, 3 and 12 add up to 15. 3 plus 12 is 15. That must be the pair we want to use. So we're going to use that pair of values as the middle terms, or our x terms. So how does this look? Well, remember, oops, got cut off just a little bit. So we started with the expression 2x squared plus 15x plus 18. And we know that 3 plus 12 makes 15. So I'm going to split that 15x into 3x and 12x. And everything else is going to stay exactly the same. And so what this should look like is this should look like our factoring by grouping setup, right? We have 4 terms here, and we can split it up into pairs and factor by grouping. So this was step 7 here. Step 8 is to factor by grouping. So I'm going to split it down the middle, and I'm going to look for my greatest common factor of each individual pair. So first, 2x squared and 3x have a greatest common factor of x, leaving behind a remainder of 2x because x times 2x is 2x squared, and positive 3 because x times 3 is 3x. And my second pair, 12x and 18, both of those numbers are divisible by 6, so our greatest common factor is a positive 6, and our remainder is 2x plus 3, which is exactly what we wanted, right? We want that remainder to match, and so that leaves really step 9. Just like we practiced before, we're going to use the greatest common factor in both terms to write in factored form. So our final factored form is going to be 2x plus 3 times x plus 6. So remember, we use the expression in parentheses, and then we take the values that we had factored out. Now, this was a lot, right? But if you trust me just a little bit, with a bit of practice, it gets easier, it gets more intuitive. Now, if you're still thinking, I'm not ready for this, I might make some mistakes here, let's remember step 10 that maybe didn't get written down, is we can always check by multiplying. So like I said, we're going to make mistakes, but if we can catch our mistakes, we can fix them. So I'm just going to do a quick step 10 to prove to you that this is the factored form. And this time I'll use the box method here. So 2x plus 3 and x plus 6. When we multiply, we're going to get 2x squared, 3x, 2x times 6 is 12x, and 6 times 3 is 18. And so when we put all of that together, we get 2x squared, 12x and 3x make 15x plus 18, which is exactly what we started with. So yes, it's a lot of steps, but the steps are very much always the same. And again, our goal is to be able to factor by grouping. So it's really kind of these middle steps that maybe take the most thought there. So let's practice a little bit more. So example 2. Example 2 is 6x squared plus 17x plus 5. First step, check to see if it's in standard form, which it is. So that's good. Second step is to check what the greatest common factor is. Our greatest common factor is equal to 1, which means we don't need to do anything else. So we're ready to identify our A, B, and C values. So our A value is 6, our B value is 17, and our C value is 5. So thinking back to our steps, we've got A, B, and C. Now we need to multiply A and C and find the factors of that. So multiplying A times C, or 6 times 5, we get 30. And we're going to find all the factors of 30. So remember, 30 can be 1 times 30, 2 times 10, not 2 times 10, excuse me, 2 times 15, 3 times 10, there we go, and 5 times 6. So we've got all of our factors listed out, and we need to pick a pair. Which pair should we pick? We're going to pick 2 and 15 because 2 plus 15 equals 17, which is our B value, and that's exactly what we want. So we're going to take those two pairs and we're going to use those to split up our middle terms. So thinking about our original 6x squared plus 17x plus 5, we're splitting that up. That 17x is going to be 2x plus 15x. And we've still got 6x squared and 5. And again, now we're factoring by grouping. So splitting that in half and looking at the greatest common factor of each pair. So 6x squared and 2x have a greatest common factor of 2x, leaving behind 3x plus 1. Don't forget that plus 1. Even though we pull the 2x out, we don't have a 0 left behind. We have a 1 left behind. And 15x and 5 have a positive 5 in common, which gives us that identical remainder 3x plus 1. So our factored form is going to be 3x plus 1 and 2x plus 5. Just a few more examples here to make sure that we're getting this. So example 3, this is in standard form. Our greatest common factor is equal to 1. Our A, B, and C values are 2, 9, and negative 5. So again, we're going to start by multiplying A times C and listing out those factors. So A times C, or 2 times negative 5, is negative 10. So when I think about the factors of negative 10, I have to be really careful here because I could have 1 and negative 10, but I could also have negative 1 and positive 10. So when I list out my factors of a negative number, I really have to be mindful of all the possible combinations. So I need to pick a pair here. I'm going to pick negative 1 and 10 because negative 1 plus 10 is equal to 9, which is our B value. So I'm going to use that to split up my middle term. 2x squared plus 9x minus 5 is going to become negative 1x and plus 10x. So again, factoring by grouping 2x squared and negative 1x have x in common, leaving behind 2x minus 1. And 10x minus 5 have a positive 2 in common. Excuse me, not a positive 2, a positive 5 in common, leaving behind 2x minus 1. So again, I'm confirming along the way that I have matching expressions inside the parentheses. If those do not match, I've made a mistake. And mistakes happen, but we can't just ignore them. So 2x minus 1 times x plus 5. Example 4, again, is in standard form. The greatest common factor is equal to 1. So I'm going to find A, B, and C. My A value is 3. My B value is negative 7. My C value is negative 6. So next I'm going to multiply A times C, which is 3 times negative 6, or negative 18. I'm going to find all my factors of negative 18. So I need, let's try 1 and negative 18, or negative 1 and positive 18, 2 and negative 9, or negative 2 and positive 9, 3 and 6, or excuse me, 3 and negative 6, or negative 3 and positive 6. So I need to choose my pair carefully, and I'm going to choose 2 and negative 9, because 2 minus 9, or plus a negative 9, is equal to negative 7. So 3x squared minus 7x minus 6 will become 3x squared minus 2x, plus 2x minus 9x minus 6. And when I factor out the greatest common factor of each pair, I'm going to get x times 3x plus 2. And remember, I need my remainder to be 3x plus 2. So I have to be really careful with what I factor out of that second pair, 9x and minus 6. So I'm going to factor out a negative 3, so that I'm left behind with a positive 3x and a positive 2, which means that my factored form is 3x plus 2 and x minus 3. All right, just one more example here. You're doing a great job. Once again, this one is in standard form. It has a greatest common factor of 1. We need to identify our A, B, and C values. Now, looks like we don't have an A value in front of x squared. So remember, if we don't have a number in front, there's really a ninja 1 there. So our A value is 1, our B value is 2, and our C value is negative 15. So again, back to multiplying A times C, which in this case is 1 times negative 15, or negative 15, and we need factors of negative 15. So 1 and negative 15, negative 1 and positive 15, 2 and, 2 does not go into 15. Let's try 3 and negative 5, or negative 3 and positive 5. So thinking about those factors that add up to 2, right? These guys add to 2, so we're going to use those. And we get x squared plus 2x minus 15. And when we split up that 2x into negative 3x and a positive 5x, then all we have to do is factor by grouping. So checking out those pairs. So we get x times x minus 3 and 5 times x minus 3. So my remainders match. I can pull those expressions out, x minus 3, x plus 5. So factoring trinomials is a really tricky thing. It takes a lot of practice. And, this would be a difficult concept even if we were meeting every day in class. So please don't think any less of yourself if you're having a hard time with this. I encourage you to try a few things out and get in touch with me if you need anything, okay? You're doing a great job. I miss you, and hang in there.